This is an example of a building which will be modeled in Revit and then analyzed in robot structural analysis. It's a two-story building with concrete frame on the first floor and steel frame on the second. The dimensions are shown here. The elevation view, and the requirement is to find for the combination of self-weight and the live load of 3 kilonewtons per meter squared, bending moment shear force diagrams on the beams on both floors, and displacement and stress diagrams, and axial force in a column. Taking slabs as one way, spanning slabs. First, in Revit, we can model this, creating the new structural template. And starting with elevation view, the first floor is 4 meters, and then the second 7, which will be level 3, is, so it's 3 meter offset. Going back to the plan view, the grids, $8,000, and 2,000. In the other direction, the first grid is A, and all the further grids are at 5 meters distance. Starting from level 1, columns, taking a concrete column as a base and modifying it, so duplicate 300 by 300, changing dimensions, and the columns span to the second floor, and we can put them at grids only on the 2 leftmost grids. So like this, and finish. Modify. Now going to the second floor, second level, the beams, concrete beams, can be placed. Beam, and 300 by 600 beam already exists in the list, so we don't need to edit anything, and we can place these beams on the grids and finish. Now these beams are spanning, actually they have overhangs, so need to be extended to the grid 3, to grid number 3, all of them. Next, after placing the beam, we can place the floor and edit type generic. We can choose generic floor and edit it. First we can duplicate and rename it RC slab and 200, and edit the thickness and edit the material, which will be C35 cast in place concrete. Now to place the slab, the offset should be 200. We can choose the rectangle and starting from the corner to the top right corner, which is a bit difficult to do, so I'll have to zoom in a bit more. It is necessary to zoom in a bit more. Okay. And span direction is this one, and we can accept this and go back to the zoom to fit. Next we can now place the columns on level 2. These will be steel columns now, and because that column we need is not available, we can just choose any steel column and either here load family or edit type and load. In the course, in the libraries UK, we need to select structural columns, steel, chorus advance, UKC, and the section we need is 254.254.132. Okay, and the columns will be at grids. Not first of all, they go to level 3 and they're at grids at the 2 left grids only. Finish. Now going to level 3, we can place the beams and the primary beams. Primary beams we can load and need to go back up to structural framing. Steel and course and UKB, and we need 406.158.74. so 178 74. Okay, okay, and again on grids and finish. Now we will also need to place secondary beams, and the secondary beams are 305, 165, 46. 305, 165, 46 is not in here, so we would need to first load this UK beam 305, 165, 46. Okay, and now going to beam system. 3516546 is here. We can place tags, and the spacing between the beams can be set to 2000, but best is to change it to maximum spacing, and the tag style is framing. And we are placing, undo, 2000. That's it. Modify. And now the floor, which is the same floor as before, same height offset. Need to zoom in a little bit. Zoom in region. And choose the now this is choosing the center lines of the beams. If we want the slab to be slightly offset to cover the whole of the beams, we can click on modify, select the whole perimeter, and then add the cantilevers to, if the beams are 158, so we can add perhaps 100 millimeters cantilevers. Sorry, not 100, but minus 100. Alright, and the span direction is now correct, so the slabs are all spanning in the direction as shown, so I can accept this. And that's it. Looking at it in 3D view with the perhaps shaded option, looks fine. One extra thing we need to do is to make sure the columns are all C35. Grade C35. So in here in the structural material, C35. The reason why this has to be done is robot needs to be given the grade in order to work out the structural property of the material. So just cast in place is not enough. And now the same for the concrete beams. Select all instances, and in the material tab change it to not C45 but C35. And I can also go to the level 1 and add some foundations. Structure, isolated footing, perhaps edit type, duplicate, and maybe I'll just make it a square. Square footing 1200 by 1200. Add columns and finish. And again for the footings, the material is C35. Now this is the structure fully modeled, but now we can also apply the loads, the live load, and that is in the Analyze tab. Loads. We choose hosted area load, which will apply the load on the slabs, and here the load case is live load. We are applying the live load. The self-weight will be applied automatically, and just changing it to -3, and then applying it on the bottom and the top floor. And after that we can send this to the robot structural analysis. Don't need to see the report, so hopefully that is all correct. Now we will need to go to loads and create a load combination. All these various load cases that are created automatically in Revit can be deleted because we need just dead load and live load, and combination can be created here. I'll give it number 3, and it consists of the dead load with a factor of 135, and then live load with a factor of 1.5, and apply and close. So now we have 3 load cases: dead load, live load, and dead load, which is self-weight, live load of 3, and a combination. And before calculating, we need to modify our structure a little bit. In the geometry, the 2 floors 2 floors have the calculation model shell. We want to change it, so we can go to the geometry, properties, and panel calculation model, and I will delete some of the models from before. And create a new one and call it a one-way slab. Tick the no finite elements because we are using just for one-way slab simplified triangular and trapezoidal method, and click add and close. So this new type of calculation is going to be applied on the selected slabs, which are 46 and 47. So now it is showing here as well that these slabs are calculating with this method. After this, we also need to change the beams which are by default rigidly connected, but they can be changed to pin-ended. So by going into geometry, releases, and choosing pin-pinned, I can now apply that to selected beams. And if I want to apply it to all the beams in level 3, I can click on that, and it here shows me which ones they are, and apply. So all these beams are now simply supported. I can apply the same pinned criteria to the beams in the direction so which are the beams 9, 11, 9, 10, 11, and also these ones which are not clearly visible, 14, 13 and 12. So it's basically 9 to 14. This beam here is can be made pinned at the end, at the first end. And the beam goes over this column. So this will be also pinned, I suppose. So this apply to beams 18, 17, 16 and 15, so 15 to 18. And close. And now we can calculate. There will be warnings of instability because of the old pinned connection, but we can ignore them. Close. And now we can go to results diagrams, and check perhaps the reactions in the Z direction. For the reactions here at the bottom of the screen, we can scroll down and see the total sum of reactions for the specific load case. So for live load it is 810. If we add, if you by hand calculation add the live load on this structure, on the two slabs, it should give us 810 as well. So by unticking this, we can now go on to show the bending moment, shear force, and axial force diagrams, choosing the beam that we want to display, perhaps this one, the secondary beam, and clicking here we can just display, and rotating we can just display the diagram on this beam. For example FZ force, apply, and changing the load to the combination, and then normalize. To see the actual values we go to parameters, labels, and apply. So we get the value of 55.9. And that's for the shear force. And then for the moment, my, it's around 70. Going back to the whole structure, we can now display for the beam B, which is this one, also the shear force diagram. First separate it, rotate, and FZ. And again we need to enable the parameters. So this is 77 maximum, sorry, from dead load, but from the combination it will be 172. And the moment, normalize, it will be 455. And displaying the whole structure again, we can now look at our concrete beam and show for it the bending moment and shear force diagrams as well. FZ, action, FZ, apply, normalize, and parameters, labels, apply. So it's 219, 281, 220, 261, and we can show also all values. So this is 120. And for the moment diagram, from combination 401, 166. This will be for the beams, and now for the column B. B2, the axial force from the combination. Just displaying for B2 is 658. And that oops, I'll hide the effects. And we can also show the stresses. So for the beam, steel beam, stress, normal stress maximum is 344, and shear stress TZ is 48. For the concrete beam, that's the normal stress, much lower, so it can be normal as 22.3, and the shear stress is 218. Untick. And we can also show the deformation, which is in millimeters from the combination load or from the live load. Exact combination on bars, 19 millimeters maximum deflection, and that is basically all for this example.